everyone. Thank you for coming today, today, and welcome to the 15th GDG Android Athens meetup. Today we have the honor to have two speakers. We have Iveta from Slovakia, we have Prague from STRV, and Yannis Smaragdakis from the University of Athens. And today we're going to discuss about MVI architecture and about optimizing the Android. I'd like to thank, first of all, the sponsors of the event, the two team, University of Athens, STRV for the drinks and Iveta for the pizzas. So we're going to start right away. Iveta, can you join us?
So user gives an output by clicking on the mouse is an input for the intent function. Then the intent function produces the result, which is an input for the model function. And the model function produces the new state, which is an input for the new function. We are not coding a user, so the final function looks like this. And this function is a pure function. Pure function is a concept related to functional programming, and it basically doesn't have side effect. That means that whenever you pass the same input, you get the same output. So its output value is determined just by its input values without observable side effect. So for example, this is a pure function because you can run it 100 times, and if you pass the same input, you get the same output. And this is not a pure function because you do something else which is not related to some function. And this is not a pure function as well because your input value is dependent on e value, which is like output of the function. So if you run it 100 times, every time you can get a different result. So this is the basic graph of the MVI architecture. The main difference among another architectures is that the user is also included. Intent here is not the Android intent as we know it. Intent here means intention. Intention to change the state of other app by an intent. The model function then takes the output of the intent function and it produces a new state. The model function is the only place where you actually can create a new state. And then there's a new function, and the new function will just render the state on the screen. I mentioned the word state a couple of times, so we're probably asking, what is the state? So imagine that we have an app and there is a button, and this button can be enabled or disabled. So that's the state of the button. Or you can have progress bar, and this progress bar can be visible or invisible. So that's the state of the progress bar. From the developer point of view, the state is an immutable data structure. At every moment in your app, you can have just one state. So your state is your single source of truth. And if you want to change the state of your app, you can do that by just creating a new one by triggering an intent function. So here you can see quite common screen displaying the list of items. So let's go to model state right now. Firstly, we want to fetch items from the API or from the database. So the display progress bar is an indicator that something is going on in the background. We have to create a new state with is loading equals true and render the state on the screen by actually displaying this progress bar. Now loading is completed, so we want to hide the progress bar, so we have to create a new state with is loading is false and hide this progress bar. And to display the empty list on the screen, we have to create a new state with the fetch to the empty list assigned to the unused attribute. And the next thing is refreshing, and to display this to the refresh indicator, we again have to create a new state with is refreshing equals true and render the state on the screen. And as the last thing, the part of every orbital is error handling is used in our way. So an error is just another state of our app we want to display on the screen. So to display this kind of state on the screen, we have to again just assign our error attribute and render the state on the screen. Yeah, and another question on you can be, why do we need it? So there is a term called state problem, which should be kind of like motivation for you to consider defining the state. So let's see the state problem in action. This is a code example which I took from a project I was working on two years ago. So let's see what kind of problem we have here. all these states. Another problem is that the view model has so many inputs, which is not such a big problem if you just forward all the actions from the activity to the view model. But the view model has so many outputs as well, and we have to take care about these outputs. And if we don't do it correctly, we can get a conflict state among our view model, and business logic. If we are lucky, it can result in virtual tags. For example, like here, displaying the success state and the progress state at the same time. But if you are not lucky, you can get an unreproducible bug report, which is very impossible for you to fix it. Do you remember me talking about group functions? I wasn't entirely honest, because if you think about it, every Android application is full of side effects, because we have API calls, API calls, we have database operation, and remote logins, whatever, and all these actions are actually side effects. So how can we handle that? There is kind of hidden component which takes care of side effects. So we trigger an input function. The result of the input function is passed as an input value to the module function, but at the same time, this input function will ask another entity to take care of side effects. And the result of the side effects can be either nothing or, let's say, another intent function which will be passed as an input value for the model function. If you are confused right now, just don't worry, because it's kind of different way of thinking. You know, I guess that everybody needs time to get used to it, but don't give it that into account, I promise. And in the second part of our presentation, we are going to build a screen of the demo app by using this architecture step by step. I have a kind of a lot of code in my presentation, but don't look at it too much. Just listen, because this presentation will be available online on the public link. So just keep on listening and check it later if you need it. So at the beginning, our architecture is like this. We haven't written anything, we have just a user ready to give us some intention to change the state of our app. And we have to define this intention. So what can the user do on the screen? The user can start the screen, he can refer the screen, he can add country to the favorite list, he can remove the country from a favorite list, and he can apply filters. And what we have to do now, we have to translate this list into Kotlin code, and Kotlin classes are based on this. So we have defined all inherent code user intention to change the state of our app. And now we have to transform every intent into observable string of intent and merge all these strings into the one to have just one output from our activity confirm. In case of one intent, it's super easy because we just have to forward. We just have to create an observable string from intent and pass this value to the intent function. If we have more intents, we have to do the same thing and merge them together. So we have built our intent function, we go to immutable intent function. And now we have to transform our string into something which is more suitable for the user. Why do we need it? Because our business logic doesn't have to understand our UI. Our business logic doesn't have to know what is inside of everything. This is the reason why we are going to transform a string of intents into a string of actions. So we have to do the same thing as we did with our intents. We have to define all the actions that we want from our business logic. Then we have to transform this list into flavor, we use self classes, and the last thing, we have to map going to show you just one example, and it's called countries function, which is an observable transformer taking action to the input and returning a result from output as well. So here is the place where we call our size effect, our API, or our database operation. In case of success, we have to wrap our result into an immutable result success object. In case of error, we have to do the same thing, but we have to wrap the error into an immutable result error object. I'm using on error here instead of on error because as you probably know, on error in Java would change the string, and we don't want to do that because the error is just another state of our app which we want to display on the screen. So we want to create an error state and keep our string alive. Then subscribe on server, and as the last thing, we want to display progress indicator, and for that we have to emit another immutable progress result object. So we got the result from our business logic, and now interesting for creation of state. To do that, I'm going to introduce a new concept, Redux, which is a predictable state container for JavaScript apps. It consists of three components: state, result of our action, and reducer. And the reducer takes the result of our action and previous state into two parameters and returns the new state. Redux is pure function. So no surprises, no side effects here. There's a calculation of the state. How is it going to code? So we have defined three kind of actions, so three kind of results, and for each kind of result we have to create a new state. And this is where our story again we have already seen it, so once again. In case of success, we are not loading anymore, so we have to set more macros, and we have to assign the which country list into the countries attribute. If we get an error, we have to create an error state by assigning the error to our error attribute, and in case of progress, we want to distinguish, we want to display the normal progress indicator or the equal to effort progress indicator, so we have to adapt our state. So we got the state, and now it's super easy. We just have to render the state on the screen. And we can do this by calling the render function instead of our activity or fragment, where we have to define all other displaying business logic. Or we can take advantage of data binding, and we can move all this logic into the XML layout to make our code shorter. So we have finished the circle, we made everything happy, so let's go to repeat what we have done. We define all the intentions, all the user intention to change the state of our app. Then we transform this intent into something which is more useful for the business logic. Then we split the string, we call the proper business logic, and we manage the string better. We create the new state by using our user, and we display this state on the screen. We got the unidirectional data flow, which means that all the data in our app follow the same lifecycle pattern, which makes the logic of our app more predictable and easier to understand. One of the most discussed questions in Android development is the question of complex state. But the state here is super easy because all you have to do is just to display latest state. And this architecture is not something that I made up by myself. There are so many companies which use this state principle. For example, Spotify, Airbnb, Tinder, Badu, etc. And summary. So, what are the advantages of this architecture? There is no state problem anymore. We got unidirectional flow between personally think that, navigation, it's kind of like, doesn't change the state of the screen, it changes the screen, and especially now with architecture profile for Google, I think it's about this quality active, because I think that it doesn't have anything common with the state of the app, it's just, about screen display. So in this demo app, I call navigation reactive, because I found it there.
How do you handle this kind of one-time events? Like, you want to show a house, but you don't want to have it in the state.
Yeah, this is not so nice in the architecture, because you have to create, I handle it in this demo app, by the way, I created a state where like show message equals true, so I display the message, but then, for example, if you change the screen, if you change the orientation of the screen, the state will be the same, so the message will display again. So I use ArcGIS as a nice operator for that after, I don't know, 2 seconds, I created a new state where it is show message equals false.
Let's take together.
I have a question.
So, you mentioned that there's a lot of boilerplate code. Is there any way to generate that with that up?
Hi.
Okay, so you mentioned that there's a lot of boilerplate code in order to set up this architecture. I was wondering, is there any tool to maybe generate some of the code or something that leaves out all this?
So my architecture will show you is kind of detailed, you don't have to use so many functions. It's the same thing as, for example, with a class or with a method. You as a programmer should know where the function is to be displayed. But for these libraries, I have it here. Yeah, and these libraries can make your life easier because they have so much magic design, and you more or less just define default state in action and define the register and side effect, and everything is handled very simply.
Thank you.
Hi, and thanks for the great presentation. I would like to ask you about the libraries here. How do you use any of these? Think one aspect on the other?
I haven't used any of them in practice, but I had a lot of good feedback about Spotify library. And another thing in my company that are actually using, I don't know the special pronunciation for that, EDRs, from MVV, and they are kind of active in this library.
Okay, let's give a big round of applause for Iveta. Let's welcome on the stage Yannis Smaragdakis from University of Athens.
Petros Tapoulas and Kostas Aidis. They've all worked on this service that I'm going to present today. So we're going to talk about full program optimization for Android. I'm going to tell you a little bit about the kind of work we've been doing, our research over the past few years, and how we think this may be useful as a service for Android. I have a reason why I'm here. So we're all looking for early collaborators. We're looking for early adopters for our service. So please keep this in the back of your mind while you're listening to my talk. So we're going to be looking. I'm going to present an approach to optimizing Android applications, and you'll see what kind of benefits you can expect. We'll see a short demo at the very end. And if you're interested, you can adopt this with our help. The idea is that we are still developing all the UI, we're still developing the services. It's not ready for prime time yet. So you need to work with us if you want to adopt it, but you're getting it for free. So in that sense, that's something you get out of it. But you'll need to spend a little bit of your time and also trust us. So that's my early bit, and you'll hear it again. So what do? As a research group, we do static program analysis, which means we try to discover what a program does under any possible conditions. Discover program properties under all possible inputs. So we have a specific technology that we've developed for doing this. This is something that's been part of our research for the past 10 years, or over 10 years really. So it's a long line of research. I'm not going to talk very much about the research results, but you'll get a glimpse perhaps of the kinds of things that we focus on in this research. It's really good research results, let me just say, to self-promote. So we have lots of top publications on this and very good funding, and I'll mention this a little bit later. So, and we do it, of course, because it's interesting, but we also do it because we think it has interesting applications, and we think the Android space is a great domain for these applications. So we will try to optimize Android apps, and hopefully with your help, like I said before. So traditionally, the reason to do static program analysis is either to do optimization. Most of the optimizations that actually take place in practice are inside compilers, so they are intra-procedural optimizations, things that happen in the context of a single method. So you may remember data flow analysis from some compilers class some time ago. This is the kind of thing that one can do. What we do is in the same line, but fairly advanced. So we call it whole program analysis. I'll try to explain how this is a little bit different, but we are definitely in the optimization space. And of course, there are many other applications of program analysis, or static analysis, like trying to find bugs, or trying to help with program understanding, help with refactoring, all sorts of human-guided transformations of queries, etc. But today, we are going to focus on optimization here, although you will see a demo of a browser, of a code browser. So maybe you'll get a glimpse of exactly trying to understand what the program is really doing through the help of static analysis. So our research is on a framework called Duke. That's the research framework, and we're trying to externalize this in a service we call Blue. And Duke has been a long-running research project since 2008, and it's a very powerful framework for analyzing Java bytecode, not just Android, also Java Enterprise and Java Desktop code. It does whole program analysis, which I'm going to explain really soon, and it's really what's behind the Clue service, the optimization service for Android. And we've also developed several other research frameworks with the same general philosophy as Duke. So frameworks for LLVM bitcode, for languages like C or C++, and also for Ethereum Python. Now, all of this in the research space has been quite successful, so we have pretty good publications for the past 10 years. We've gotten major research funding, both from the European Union, including an ERC grant, which is the best research level funding one can get for research, but also funding from Oracle and Facebook through multiple grants. So we do have industrial partners, as I will mention soon. I spent some time last spring at Facebook, so we collaborate with Facebook on a couple of those things. And the backend for optimization, for our optimization service, is actually a a Facebook open source optimizer, which is Redux. It's an open source project, and I'll mention it really soon. Okay, so I'm not going to talk to you very much about the research component itself, but I'll try to give you an idea of the challenges of doing what code program analysis. How is this hard? So code program basically means we're trying to model the behavior of the program outside the method level. So we're trying to find out what method calls and returns do, and also we're trying to find out what are the effects of the key. So let's first start with method modeling, let's say. So let's say we try to answer the question of what are the possible values of a variable, or to put it differently, what objects a variable can point to. So we have multiple variables here, and very, very simple program, mostly pseudocode. So we have variables A and B in method foo, variables A and B in method bar, and then we have an identity function down here. And the idea is, well, let's try to see what an analysis might do there to do code program reasoning. Well, clearly the analysis will try to propagate values and try to see where these values end up. So, for instance, a standard approach in static analysis is that we approximate, we represent all objects that are allocated by this instruction. This instruction here, it could run 1,000,000 times at runtime. But all of those objects, we will represent them as one static object, just because they have the same allocation size. So let's, for simplicity, say, if I want to follow the flow of values, I start from local variable A in method foo points to this object, this new A1. And local variable A in bar points to that object, which I'll call conveniently A2, new A2. Are we good so far? Yeah. So now the next straightforward inference is, if I want to ask what does this variable point to, or what are the possible values of this variable, and I'm propagating everything throughout the program, then the answer is that this variable can point to both, right? Because I pass to ID both A of foo and A of bar. So this is correct, right? It points to both. But the moment I do this, I immediately lose precision, because whatever comes into this A gets returned back. And then my analysis, any static analysis that follows this approach, will infer that this B now points to both of these, and this B points to both of these, which is not an accurate result. It's a correct result. It gives you an over-approximation, but it's not a precise result. So these are some of the challenges of static analysis. How to maintain precision when we are propagating values throughout the program and doing it so while our analysis is very efficient. So the particular answer for this problem, for method modeling, it can take many flavors, but one easy flavor is to distinguish local variables by what are called contexts, and say here something as simple as local variable in ID. When ID gets called by foo, as this value, when ID gets called by bar, as that value, and then we maintain full precision. These are exactly the kinds of things that our static analysis has to do. So it has to do modeling of method calls and returns, and very similarly, it also has to do modeling of the heap. So I have here a slightly more complex example. It's very much like before. We pass into method link some data, and then this data gets linked into a new data structure node. And here, that's the key here, that inside n.member of a new node n, I put whatever data gets passed in. So now the trick that I played before is not enough. It's not enough to distinguish whether data gets called by foo or bar, because it always returns back the same node. So I need to distinguish something more. And in this particular case, I'm not going to bore you too much with the techniques, but the idea is that we also need to distinguish the objects themselves based on the context where they got created. So I need to distinguish new node based on where it got created. Now, why am I telling you all this? I'm trying to give you an idea, a glimpse of what is code program static analysis and what kinds of techniques our algorithms need to implement to get precision and scalability together. This is all a part about whole program analysis. And from now on, it's going to be entirely Android. So I hope you're reading. So are we okay with everything presented so far? Okay, great. So we have this framework, Duke. It's a very powerful static analysis framework for Java, developed over the past 10 years. Has lots of analysis, lots of trade-offs of precision and scalability, and it handles all the tricky cases, or almost all of the tricky corner cases of Java semantics. So there's a lot of work that has gone into that. Now, the application that we want to use Duke for is Android optimization here in this talk. So we have Blue, which is a service. It's the code name for our prototype for an Android optimization service that uses our recent result for analysis. And the thing to notice here is that with whole program analysis, we can do a lot of things. We can do a lot of optimizations very well that otherwise we cannot do equally well. So today I'm going to focus more on dead method removal, which is something that by design requires whole program analysis. I cannot know what's dead unless I find what the entire program does. It's not a local thing. It's not a local question to say what's unreachable, which methods can never be reached. So do we have any questions so far? So you can interrupt with questions. We're all good. Okay. So Blue optimization. So first of all, quick question, who's using ProGuard in their Android development? Who knows that they're using ProGuard? Okay, lots of hands. ProGuard is the default packaging tool for Android. It's the one that you get with the Android SDK. It does a very simple whole program analysis. We'll discuss this on the next slide. So it is an optimizer that some of you, many of you, are already using to do a packaging, to package your application into an APK for distribution in the Play Store or wherever. Has anyone heard of the Redux optimizer by Facebook? If you've heard of it, please show me some support. Show me your hands. Has anyone heard of it? Okay, 1, 2 people, 1.5 person. Okay, so it's an open source optimizer that Facebook is using for their own apps, or for many of their own apps, but it's actually open source. It's a C++ project that goes in and works as an optimizer, takes your APK and does a whole bunch of transformations on it, to trim it, to do lots of inlining, smush together interfaces, does lots of optimizations. It's there, it's free for people to use. It's not yet a full replacement for programming, but it's something that one can use. So the way we actually want to use Blue is that we have our own modified version of Redux, and we want to use Blue as the driver for this backend. That's actually not ours. That's a third-party backend. That's Redux. That's an open source project. You can go and use it right now, but you cannot guide it very effectively on your own. I mean, you can limit yourself to its default transformations, but these are very limited. Now, with our service, you can do a lot more. You can make it a more powerful optimizer. So the overall flow is that to use our service, at the very last step of your build process, you integrate Redux, and you let Blue directives that our analysis together with you, together with the programmer, has produced to guide this optimization. So, and you interact with our analysis through the graphical browser that I'm going to show you really soon. Is that clear, the top-level plan? Okay. So, let's focus on the primary application, which is dead method removal. So, or what one might call lead loading. Your app obviously uses many libraries. You link it with tens or hundreds of different jars that implement sometimes tiny pieces of functionality, right? And many of those you're not even thinking about. They're just there. And what we want to do is only keep the code that is truly used in these libraries. That's also what the existing Android packaging tools, namely Progar, that's what they do. But they do this with fairly imprecise analysis that's based on method names and signatures. The program has no model of how the values flow through the entire program. So it can never be fully precise. It only checks if something has a remote chance of ever being used. So by packaging only the code that we need from these libraries, we minimize the size of the distributed app. So that's where we want to come in and help with that. Do a better job minimizing the distributed APK. Are we good? Okay. Now, why does one do this? Obviously, in many settings, it makes no sense. If you are going to do just private deployment on 10 tablets of 10 customers and no one else will ever download your APK, it's not going to make any difference for you whether your APK is 30 megabytes or 25, right? But for anything that's deployed widely, there are significant benefits in trimming the size of the APK. So most of the people cite this article because that's the only public article out there. It's on medium.com, which gives some statistics on when you shrink the APK, how your conversion rate increases, how the installs or updates increase. So rule of thumb, at least for I've spoken to people at Google, Facebook, and Uber. I have not spoken formally to anyone in other companies, but at least 3 very major companies. Rule of thumb is they trust this article because it agrees very much with their own internal measurements. And it's roughly like if you trim 5 megabytes from the APK, you increase your conversion rate by 1%. So there is financial benefit, but it's for big companies. It's for people who have lots of deployments there. There's significant benefit for that. It's worth a lot, but not to everyone here. So clearly you can map this number into your own model. But the point is, if you shrink your APK, it becomes more desirable. People can download it over mobile data, for instance. People are less reluctant to update it whenever they need to. So it's much better for all sorts of market reasons. So currently, people do this with Program. You may have used it, we discussed it before. It's free with the Android SDK. It's a third-party tool, but Google distributes it free with the SDK, the basic version. It packages code, removing unreachable code. And the way to guide this packaging is that the programmer writes this .profiles. Who has written it? Profiles, not profiles. Who has guided it? Oh, okay. Quite a few. Okay, so you've seen what these look like. The 2 main annotations, the 2 main directives in those files are keep and keep class. They effectively tell the system what are the entry points to the application from otherwise obtained code. And I'll explain what that means. And our service wants to use exactly the same information to ensure analysis correctness. Now, what do I mean by that? Android is a great opportunity for static analysis tools and for optimizers because it actually gives us a platform where we have a notion of the whole program. We can close the world and only get the whole program that we care about and nothing outside of it. The problem with the correctness of static analysis is that a static analysis cannot know things that are typically considered dynamic code. Static analysis cannot know what code gets called via reflection, and many libraries use reflection, and what code gets called by native code. And your application may very well have a graphics library in C++. That's compiled in native code, but it calls back. You may also very well have some tiny piece that's JavaScript that's interfacing with your main Android application. So there's all of those things that the analysis cannot know. That's what you specify in the program key directives. You specify what entry points of the program are not apparent by just looking at the Java code. You need to understand reflection, or you need to understand JavaScript or native code to find these entry points. So like I said before, Proga does a pretty naive analysis. Our goal is to do a more advanced code program analysis, but we both use the same input info. So we want to start from the Proga key specifications, key directives, and from that compute everything that's reachable in the program, so we can trim the path. We can remove all the bloat in the APK. Okay, so bottom line is, if you have very good program key specifications right now, then you don't need to do anything. Just get the benefit from using our optimizer for free. But most people do not have very good program key specifications, and that includes the top companies on the planet. I'm not going to mention names, but we've looked at some program key specifications or the outcome of that, and based on our analysis, we have surprised many people at one of the 3 top companies I mentioned before on what their program key specifications don't obfuscate or keep around or whatever. So it's not easy to satisfy this one, but all you need in practice is to have good enough, precise enough, and thorough enough key specifications for your program profile, and then you get lots of benefit. You just run our optimizer, and it trims a lot of that on that problem. Now in practice, the more practical cases, your program keys are not as precise or thorough as one would want. Or maybe they don't even exist. You don't use program at all. So in this case, what you want to be doing is using the Glue browser, the assistant that I'm going to show you pretty soon, to produce or maintain the right directives for Glue. Now, essentially, what you'll be doing here is maintaining remove directives for get code. So the first approximation, just think of it as you'll have a long list of remove directives. These are the parts of libraries that are truly unused, but program does not know that they are unused. And that's what you maintain with the help of our system. And then you run optimize, and it goes and trims those from your code. Are we good? Okay. So, like I said earlier, we're here because we're looking for early adopters or alpha testers or partners. And what you get is pre-optimization, and you get to play with fun technology and excellent people like these guys back there. What you give is probably, I mean, that's not the only option, but that's probably the best option. You give us byte code that does not have any obfuscation, or you can give us source code, it's up to you, or you have us visit you and we try to install something on your end, or you give us obfuscation mappings, what program produces. You give us a little bit of your time and a little bit of access to your build process, so we can put a modified Redux optimizer at the very end to trim the path, trim the remove methods. So you give us a bit of access and we get free optimization, which we hope in the future to be offering as a commercial product. So this is a good time for me to give you a bit of a demo. Let me start from the very, very beginning. This is a tiny font, right? Can you read this font? Yes. Okay. So the idea is we have a concept of projects and bundles. Bundle is a specific snapshot of the code. And once we open all that, you get to browse the APK and ignore the visualizations here. They're just there for fun. The main thing to note is something like these directives. This particular one, you can't read this, but it says current analysis configuration. I selected an analysis up here. That's what the current analysis said we can remove. So the APK I'm looking at is the Signal app. Signal is a free encrypted messaging app. You may be using it already on your phones. But it's open source, so it's a great thing for us to be able to demo on that. And here you will see that the analysis computes directives for many, many methods. In practice, you'd like to trim that down. The idea is that Clue, the UI that you're looking at right now, is a management UI, is a service for managing those descriptors, those directives. So we have notions like the current analysis configuration, and then the current bundle configuration, which is what's going to be used as input either to a reanalysis or to the optimizers themselves. Now, the idea is that you interact with this, you go to the code, and you approve or don't approve the remove annotations that the analysis has computed. So let's try to look at one of them. Let's take, for instance, this support remove here. Okay, barely enough font size. So here's the method, support remove, that our analysis has computed to be unwritten. So what's going to be your line of thinking? What's the process of going through this and saying, yes, I want to trim that method? This is obviously a method in the library. The first reaction will be, well, this is called from somewhere. This must be called from somewhere. Why is the analysis not finding this? And the kind of exploration you can do is that you go to this analysis enhanced code browser. And sorry about that, but there's not much screen real estate with this resolution. But the idea is that the analysis will tell you where this method might be called, but in fact is not. And then you go through and you explore this code. So you go to method remove. In this case, we didn't use source code, but we used unobfuscated bytecode, just to demonstrate that you can do things with unobfuscated bytecode. You look at things in a fairly low-level intermediate language, but you really don't care because most of the symbols that you care about are still in the code. So in particular, in this case here, you're trying to find out why this call does not really discover that the function is callable. And the answer is because nothing passes this cast instruction that one instruction has up there. So this value here, which comes from this iterator next, is never a safe iterable map support remove. So then you can do some more exploration. You can say, this particular class, where might it have been used? There's a search facility. You can go through your code and establish what's being used and what's not. In the end, the idea is that what you're maintaining is these configuration files. In most of the cases, you do reasoning per packets. You say, for this library, oh, I can see that I'm not really using all these methods. I can see no place in my code where these might have been used. And for this, you may need some help from the browser. At the very end, you maintain what you have approved or what you have not approved for the optimization. At any point, you can click optimize, or more likely, you can export the optimization directives. You can get them in a form that you have already integrated as an input to your build process, and completely offline, you just add this file that which has keeps and more importantly removes here, and it's used to optimize your build. So that was my very quick demo. I'm not sure if I confused you by showing too much. So did we follow roughly what the browser is trying to do? I mean, the browser is only there so you can get some confidence in the results of the analysis. Or to put it otherwise, it's only there so you can know what are the entry points. And most of the information that we give is, here are extra entry points, which is exactly what you would do with programming. Here are more keep annotations. When you package my application, you will need those to package it correctly. And as long as you give us correct keep annotations, the analysis will also be correct. It will produce correct remove annotations, remove directives. So that's the idea. Any questions at this point? Yes?
When you select a keyword function, it will generate the use unified to verify the priority optimization. So it's like generating the proper file.
It's not generating the proper file because at the very end we're not using proper, we're using readers. So it will read directly the key. directives. We're using our modified backend optimizer. So it will take the keep directives themselves. So the keep directives have two purposes. First, they are input to the analysis. So the analysis knows that all those methods are reachable. So that's the first use. And